beams is the same. 0 degree, 15 degrees orientation, 30, 45, 60, and 75. Так, do you hear me? Gentlemen. Okay, if you have some questions, please stop and ask. Manufacturing process the same, but during manufacturing, some variation of dimensions can happen due to linear expansion, due to non-uniform spreading of polymeric resin through the fibers. So we will calculate the average dimension of this beam. So we need to know the height, the width to calculate inertial moment. We need to know the length of this beam to calculate the deflection according to known formulas from the mechanics of structural materials. And for this purpose, we use very simple installation. So it's wooden rigid beam basement, and the device which simulates the clamping. So I can insert this beam, then tight the screw. So it means here I simulate the rigid clamping. It's not absolutely, but we assume, it's our first assumption, this is a rigid clamped beam. Then we have known for you from the course of interchangeability dial indicator. Dial indicator permits to measure deflection. For more precise measurements and deformations of beams, local, we can use tensometric strain gauges. For absolute deflection for this slab is quite enough to measure the deflection or sagging of this beam. So you remember that this dial indicator has divisions. One revolution of a long finger means deflection of 1 millimeter. We have 100 divisions, so the spacing between any neighboring division is 0.01 of millimeter. So I can attach to the special device, also clamping device, this dial indicator. Clamp it with a screw. And we can see, so if we apply lateral force, the finger rotates, and we can measure deflection expressed in doles of a millimeter. So for this purpose, we use hook and small platform. On this platform, we can hang weights of known mass. Mass is stamped here. For example, here we can see 100 grams. Then for calculation, we will convert grams to international system, so we will operate in newtons. I will consequently hang such weights one by one, calculate the total weight, convert to newtons, and measure by dial indicator corresponding degree of deflection. And if we know rigidity, you remember rigidity is the product of elastic modulus by inertia moment. So inertia moment, you remember, it's given in your lab with drawn formula from the course of mechanics of material. It's width multiplied by thickness cubed by 12. So our task is to measure how deflection of beam depends on orientation angle. So we have 6 representatives, 6 beams with different orientation angle. So, and we will apply also 5 weights with definite increment. Obviously, more rigid beam, more weight we need to apply. So manufacturing process is the same. So it's forming in rigid dies. Temperature and duration and applied pressure is given to your manual. You can read at the beginning. So I can open also. Scheme of testing is shown on the figure 1. The real installation you can see. So let's start our measuring. So in current situation, I will do it in offline form. You have to do it by yourself. So let's start with beam with orientation of fibers 0 degree. 0, I repeat, it's along the length. I take this beam. So please open your manual. So let's start with measurements and of deflection, then with geometry. It's page 6. Page 6, table 2. Specimen number 1. You can write near specimen number 1. You can write in the column number 1 0 degree to understand what does it mean specimen number 1. No, because we can start from the any. So now our task is to fill first column. We will fill Q sub 1 for the specimen number 1 and corresponding value of deflection, the osegin, V sub 1 in millimeters. Then we will calculate elasticity modulus. Then after application, next weight, go down and fill Q2 and V2, then Q3 and V3. Clear? So I adjust 0 here by means of rotation of this scale. So I installed 0 on the dial indicator. And I apply weight with mass 100 grams. 100 grams, it's 1 Newton. Please write in the table Q1 for specimen number 1 is 1.0, 1 Newton. If we read, we can get 0.68. Please write 0.68. It's deflection V sub 1 for our beam with 0 degree. Right where the cell corresponds to V sub 1, 0.68. Then next increment, we add one more 99 grams. So totally it will be 199. Please write in the table 6 below next stage of loading Q sub 2 for specimen number 1. 1.99 newtons. 1.99. So we can see that our finger made one revolution. It passed through the 0, and the second revolution has already started, and deflection is 1.25. 1.25. Clear? Then next increment of loading, we add one more piece of weight, 99 grams. So totally Q sub 3 will be 2.98. 2.98. Deflection V sub 3 for the first specimen is 1.85. 1.85. Then we add one more increment, 48 and 49. So totally U sub 4 is 3.95. The deflection is 2.45. V sub 4 for the first specimen. 2.45. And the last increment of loading, I add more several weights, and total force applied, lateral force applied is Q sub 5 for the first specimen, 4.83. 4.83. The force in newtons, 2.84. 2.84. First column is field, Q and V. Yes? So now I unload the system. I draw your attention. First assumption I told you. Here we assume that clamping is fully rigid. Such questions will be in your tests, which you have to pass this lab fully, finally. Basement is rigid, no hesitation. Then, third assumption, I draw your attention. Here we use dial indicator. Dial indicator has a spring inside. Strictly speaking, when we apply load, spring by itself restricts deflection also. But we neglect with this resistance of a spring. We assume that resistance of this spring is negligible. No influence. Deformation force is fully elastic. No plastic deformation. No energy losses on heat or another physical phenomena. Zero degree. Next, 15. Beam with 15 degree with the same approximate cross section. Cross section we'll measure later. The same procedure. So I install beam. Then, when you understood how to conduct, we need some parameters also of this installation. For calculation of our elasticity modulus for these beams, we need some parameters. Please look to the formula number of item number 12 in the precision of work. We need to know coefficient K. Coefficient K depends on total length L capital and the coordinate of the point at which we measure the deflection, distance A. These parameters are designated on the figure 1. So let's determine. So I take the ruler and measure the spacing from the rigid clamping up to the point where we measure the deflection and the total beam length where we apply lateral force. So we need two parameters. The first one is 0A, parameter A, 0.275 of meters, expressed in meters, and total length L capital is 0.365 of meters. Clear? A is 0.275, L capital 0.365 meters. So these parameters are the same per each beam. For a beam with rigidity 15 degrees, we will use the same increments of loading because the rigidity is very close. It's another but close. So I attach the hook with platform, then adjust 0. and continue to apply the same weights. So you can write to the column number 2, near number 2, please write also for better understanding 15 degrees. Specimen number 2, it's beam with 15-degree orientation. And rewrite Q1, Q sub 2, Q sub 3, sub 4, and sub 5. It will be the same like for beam number 1. So 1.0, 1.99, 2.98, 3.95, and 4.83. And now our task to find corresponding sagging or deflection, vertical deflection from the lateral force applied. First weight. .55. V sub 2. .15. Third weight. .75. Fourth weight. .32. And the fifth weight. .84. Roll. So I unload. .15. Next beam with orientation plus minus 30. Plus minus means symmetrical loading. I told you last lecture to escape of warping during manufacturing and further operation, we have to keep symmetrical scheme. If we have 0 degree plus 0, we add minus 0 to compensate warping due to linear expansion coefficients and Poisson's ratios. Plus minus 30. Please, so I adjust 0 once again, 0 level. So please write beams with 30 degrees has less rigidity than previous beams. So we will reduce increment. Please write for the third column, specimen number 3, also near 3 write plus minus 30 to understand what beam do we analyze. Increments Q will be the following. Please write Q1 0.49, then 0.99, then 1.48, Q3, Q sub 4, 1.99, and the last 2.48. So let's apply first increment 0.49. Deflection is 0.59. Next, 0.99 newtons. Second weight. 1 revolution, so it means 1 millimeter, and above 1.34. Third increment. Second revolution is done. 2.03. Fourth increment. One more millimeter is done. It's 3.16. And the last one, $4.21. The same weights for 45 degree, next beam. .45 specimen number 4, please write near 4, 45 degree. column number 4. So first increment. $0.68. Second increment. $3.20. $4.74. $5.98. And the last one, 6.38. 6.38. Beam number 5, specimen number 5, plus minus 60, right, plus minus 60 in the header. For this beam, rigidity is less with previous variant. So please write increments of masses we can apply. Q1 0.19, Q2 0.38, Third one is 0.950, 0.50. The fourth one, 0.88. And the last one, 0.99. So let's measure now. First increment, 0.19. $0.78. Second increment, 1.45. Third increment, 0.50. $3.61. $5.60. The last 8.02. 8.02. And the same increments for the last beam with orientation of fibers 75, plus minus 75. Gentlemen, please answer my question. Why we don't test beam with orientation 90 degree? Why we don't test 90 degree beam? No suggestion. It will be, if you don't want to think, it's your question for your test. First, adjust 0. And first weight 0.19. 0.16. Next increment. $1.55. $4.28. $5.90. And the last one, 9.56. So we found what is the dependence of beam deflection on reinforcing angle. Then you can numerically calculate elasticity modulus. For calculation, but I draw your attention, it's mentioned in your manual. Also, it's question from your tests. That if we look to the formula in item 12, that elasticity modulus Ez sub I is equal to lateral force Q divided by deflection or sagging V sub I, inertia moment, and multiply by coefficient. So what conclusion can we make? Elasticity modulus is a constant value, it's characteristic of a material, given material. K is a constant characteristic depending on our installation. It depends on A and L, geometrical parameters. J sub X, inertia moment. Also, it's a constant value which depends on cross section, rectangular cross section, width and height. What does it mean? It means that Q divided by V, force by deflection, is a constant value. So dependence is linear. So what does it mean? When you will draw the graphical dependence, Q as function of deflection, you have such graph. Then here you will have five per each beam. Per each beam. 5 experimental points. It means that you need to join them with a straight line, not with curved line, with straight line. For example, by the method of least squares. Now we need to determine geometrical parameters, width and height or thickness of our beam. Technology influences on these parameters. So for determination of width, we use caliper, known for you caliper. So I have caliper now with precision of measuring, it's written here, 0.02 of millimeter. I will measure, please open your manual, page 5, table 1. Also, we have 6 beams, 0, 15, 30, 45, 60, 75. Per each beam, we measure thickness in 5 different places along the length. And then below, 5 values of width B from B sub 1 up to B sub 5. Then we calculate average value of delta thickness and average value of B width. Summarize and divide by 5. Then variation coefficients. Coefficients of variation tell us what is the precision of manufacturing, what is the scattering of these parameters. J sub x is the inertia moment. So I measure width and thickness in 5 different places along the length. Thickness I measure with micrometer caliper. Also, you know it from the course of standardization. Micrometer guarantees the measuring of parameter, the thickness, with the precision 0.01. It's written on the micrometer of millimeter. Why do we use micrometer for the thickness? Because thickness is cubed in the formula of inertia moment. So if error is presented, or scattering, not maybe error, but scattering, and this scattering is very high, cubed, it will be higher. So I need to know more precise, as much as it possible, the value of thickness, for which we use caliper, because B in the first degree is included to the formula. So please open your table, specimen number 1. So I will tell you values of delta, 5 values of delta, then 5 values of B. Delta sub 1 for the 0 degree beam, 4.95. along the length delta 2, 4.99. Delta 3, 5.02. Delta 4, 4.98. Delta 5, 5.12. So you can see that variation of height along the length is presented due to some distinction of manufacturing process. Then width B sub 1 because of 0 degree. $20.32. B sub 2. 20.26. B sub 3. 20.16. B sub 4. 20.20. And B sub 5, 20.46. $15. Delta width at first width B at first B 20.48. $20.16. $20.04. $19.88. $19.90. And thickness delta. $5.08. 92, 5.20, 4.86, 5.05. Specimen number 3, 30 degree. Delta thickness 5.24, 5.32, 5.22, 5.30. And the last 5.12. Width 20.16, 20.04, 19.90, 19.76, 19.66. Forty-five degree. Thickness 5.03, 5.32, 5.10, 5.06, and 4.90. Width B. 19.92, 19.80, 19.86, 19.96. And the last 19.84. 60 degree. Next beam. Thickness, delta 1, delta sub 1. 4.92. 5.06. 5.02. 5.18. And the last 5.24. Width 20.06. 19.86. 20.04. 20.20. 20.28. And the last beam 75. Thickness 5.10. 5.02. 4.96. 5.06. 5.10. Width 20.10. 20.16. 20.28. 20.22. 20.36. So now you have all data for calculation average value. Each delta summarize and divide by 5 and insert to the cell delta without subindex. The same for B, for the width. Coefficients of variation. Coefficients of variation, no, meaning of coefficient, less the value of variation coefficient, less, more precision. Item number 1 gives us formulas for calculation variation coefficient and dispersion. Dispersion, it's a parameter from the mathematical coefficient of variation from the mathematical statistics, which are characteristics of precision of the process conduction. Inertia moment, I told you it's also a formula in item number 2 is given J sub x b delta average value b delta cube by 12. So after that, you calculate K in item number 12, and per each value of Q and V from the table number 6, calculate individual value of elasticity modulus. After that, after you will have 5 values of elasticity modulus per each beam experimental, find average value of elasticity modulus per each beam, item number 13. It will be experimental results. Experimental results we will show with graphical dependencies, with diagrams. Diagram number 1, it's page 4. It's dependence of beam deflection, Q on V on applied force Q. All these 6 graphs should be linear, I told you. Linear. And then second graph, how elasticity modulus depends on reinforcing angle. This curve has a character which falls down. E phi, something like this, falling down character, and it's experimental curve, so you will draw it by the points, by markers. And also we suggest in this lab to compare experimental curve with theoretical ones. For theoretical dependencies, here is formulas are suggested. We take EZ, average value of EZ for 0 degree and for 45 degree. So 2 parameters we need. Item number 16. Select from your results E sub 0 and E sub plus minus 45. It's our first beam and fourth beam. First and fourth. Then we calculate EZ90, parameter A, and then we use formula EZT per any angle phi. So here in this formula, please insert angle phi, which varies from 0 up to 90. So 90 we can insert to this formula, in spite of no absence of this beam at testing. Why not? Please think. Why we don't test 90 degree? And on the same graph, please draw second curve, theoretical curve. And compare what is the convergency between experimental curve and theoretical. So in the conclusion, you have to write at least of 3 main thoughts. First conclusion, that dependence between applied force and deflection is linear. More deflection, more force applied, more deflection. Second moment, that elasticity modulus is non-linearly depends on angle phi. Maximum corresponds to 0 degree, minimum to 90 degree. And the third item of a conclusion that you found the experimental dependence and calculated theoretical. How they coincide? What is the convergence of your experimental results with respect to theoretical? Clear? Any questions?